Assalamualaikum and good day class. In this video, we are going to continue with the second part of chapter 2. So recall that this is our learning outcome. So in the previous video, we had covered the first one, internal architecture. So in this video, we are going to look into input and output port. So by now, we already know that PIC has two input-output ports. That is, we have port A, and another one we have a port B. So how do we know that? So we know this from the datasheet and also from the printouts on the chip itself, isn't it? So you can see pin RA0, RA1, RA2, RA3, and RA4. These 5 pins make up port A. Okay, and RB0, RB1, RB2, RB3, RB4, RB5, RB6, and RB7. So these 8 bits make up our port B. Okay, make up port B. Okay, so if we try to map up the bit names, okay, so the least significant bit is the RA0, okay, and then follow suit lah, RA1, RA2, and then RA3, RA4. So why did I draw out this box in 8 bits? Okay, because later on, when the microcontroller communicate with these ports, okay, so it will always send the data in 8-bit chunks. Okay, so even though it only covers 5 bits for port A, so still when we send data to this port, so we will send it in 8-bit chunks. Okay, so these 3 bits is not used. Okay, and then for port B, we have RB0, okay, RB1, RB2, RB3, RB4, RB5, okay, and then we have RB6 and RB7. Okay, so each of these pins is actually mapped up to these bits. Okay, so to the bits in the PIC. But then at one time, each of these pins can either be input, okay, input, or it can either be an output. So then, how can we set whether the pin is an input or an output? Okay, so this is where we can configure the bit values in the registers related to the pin. So this one we are going to look in the next slide. The two registers that are related to input-output port in PIC are called as port and trace. So for example, depending on the port, if you want to communicate with port A, for example, with port A, so the two registers that we need to access is port A register and trace A register. If let's say we want to communicate with port B, or let's say we want to access port B, then the two registers that we need to play around with is port B register and trace B register. So recall in the previous slide, we are wondering how can we set a pin to become an input or output, isn't it? So this is where we need to use the trace register. So how to do that? So in trace register, let's say trace A register. Okay, so all these registers in PIC 16F84A, usually, most of them, especially the special function registers, are 8 bits width. Okay, the punya length tu adalah 8 bits. So for trace A register, each of these bits is mapped to the respective pin in port A, meaning that the least significant bit over here, okay, RA0, is mapped to RA0, and so on and so forth. RA1, RA2, RA3, RA4. Okay, and this is not used, isn't it? But still, because the width of the register is 8 bits, then we still need to map up each bit in this register. Okay, so if let's say we want the respective pin in port A to become an input. Let's say RA0, we want this to become an input pin. And then RA1, 2, 3, we want these 3 pins to become an output pin. And RA4, we want this to become an input pin. Okay, so what we need to do is we need to write 1 to the bit that we want to become as input. So those in which we want to set as input, so we need to give 1 to that pin. And those that we want to become an output, so we need to give 0 to that pin. Okay, and the rest doesn't matter, so let's say we just write 0. Okay, so meaning that in our program later on, so we need to send this data 0, 0, 0, 1, 0, 0, 0, 1. Okay, this data we need to send, or we need to write to trace A registers later on in the programming to set the input output value. Okay, so this is how we do it. But what is the use of port register over here? Port A register, what is the use of this register? Okay, so in PIC, this port A register, we are talking about the register now, is where we can read or write the current value to the pin. Okay, to the pin. So, okay, we will look into this in the following slide. In the previous example, we already set the trace A configuration for port A. So in which RA4 and RA0 is an input and the rest are output. Okay, so we can say that this trace A register or trace register is a configuration register for our input output port. This is a configuration, either the bits become input or the bits become output. So by right, when the pin is an input or an output, so we can actually read or write to change the state of the pin, isn't it? Okay, for example, if you look at pin RA1 over here, it is an output pin, isn't it? So we should be able to control this pin, okay, so that if let's say, for example, if we connect an LED to this pin, we should be able to turn on or turn off this LED through programming. So how can we do that? This is where we need to access port A register. Okay, so let's take a look at port A register. Same as trace A register, so each of these bits is associated with the pin in port A. Okay, so for example, if let's say we want to turn off the LED connected to pin RA1 or pin 18 over here, okay, so we need to source some current to this pin, isn't it? So in order to source some current to this pin, so what can we do? We can only write the signal 1 or 0 to the pin. Okay, so in microcontroller or in digital device, so 1 is associated with a high signal and 0 is associated with low signal. Okay, so this actually when we give 1 or 0 to a pin, we are actually giving some current or voltage to the pin. Okay, so you can refer to the datasheet page 52 okay, to look at the output voltage rating. Okay, for low voltage, the maximum value okay, is 0.6 volt. And the output high, the minimum value okay, is equals to VDD minus 0.7. Okay, so this is the value of the voltage that will be supplied. If let's say we give low or high value. Okay, so this one we can look into the datasheet page 52 to get to know more. So in this case, in this pin 18 case, if let's say we want the LED to turn on, okay, so what we need to do is we need to supply current to this pin, in which to supply some current, so we need to give a high signal to the pin. In other words, we need to write 1 to pin RA1. Okay, so same goes for the rest. the rest of the pin. If let's say we want to, depends on our connection as well, the connection of the output components. Okay, so we can give a 0 or 1 respectively to control the output signal, the output pin at the bit. Okay, but for pin which had been configured as input, okay, so what can we do is we need to read, the state of the pin, okay, because it is connected to an input components. So input components can only be controlled by external user, isn't it? It can be controlled by user externally. Okay, so as a designer, we don't know what is the current state of the pin. So in order to know the current state, the current state of the input pin, so we need to read the pin value. Yes, because we don't know this one. So in order to read the pin value, so we need to access the port register. Okay, in this case, because our pin is associated with port A, then we need to access the port A register to read or write to the pin. So in order to read or write or to change the state of the pin. Okay, so that is the use of a port register. Recall that this is the features of port A and port B pins in PIC 16F84E. Okay, so port A has 5 bits, okay, RA0 until RA4, and these pins are bidirectional, in which the data direction can be set through trace A register. And only RA4 got 2 functions. Okay, so it depends on our programming. Okay, we can control these functions by looking at the TOCS bits in option write register. So this one we will look into from time to time. Later on we will come across this. Okay, and then for port B, it is 8-bit wide. Okay, RB0 to RB7, and it is also bidirectional, so meaning that it can become input or output, and this data direction can be controlled by writing the appropriate value to trace B register. And only RB0 has external or additional function, okay, which is as an external interrupt input. Okay, so this one we can set through programming and also coupled by the connection to the pin. Okay, and for pin RB6 and RB7, okay, during serial programming mode, meaning that during when we burn the chip with the program, okay, so RB6 becomes the clock line and RB7 becomes the data line. Okay, so this is when we program the code or when we burn the code inside the chip. So this is the function for these 2 pins. Okay, and another one is RB4 and RB7 also can cause an interrupt on change. Okay, meaning that it can also becomes the source of interrupt. Okay, if we configure the pins as input, okay, and then coupled with the write circuit to the pin. This is another example to illustrate the use of port register and trace register. So in this case, when we come across the word trace X, so X here means variable. Okay, variable means it can take, depending on the port that we access. If let's say we are accessing port A, then we need to write to trace A. If let's say we are accessing port B, then we need to write to trace B. Okay, so that's why we use this X over here. Okay, same goes for port also. Okay, X here means variable, meaning it will change according to the ports that we access. Okay, some PIC got more than 2 ports. Okay, they have port C, D, and so on and so forth. But in our case, we only have port A and B. Okay, so as we can recall, let's say in this example, our trace B data, okay, is given in this form. B apostrophe, lepas tu ada 1111 0000. So what does it mean by this B apostrophe? So this B apostrophe, okay, in programming later on, when we write this kind of notation in front of the data, that we have over here. So it means that the data following the bit apostrophe is in a binary format. So in some cases, maybe we want to write the data in its hexadecimal form, isn't it? So we need to have this 0x in front of the data to indicate that the following data is in hexadecimal value. Okay, so this is what it meant by B apostrophe. So here we set RB0, RB1, 2, 3 as output, okay, because the value here is 0 in trace B register. And for RB4, 5, 6, 7, it is set as input, okay, because we give this value 1, okay, in this trace B register. So this is the meaning of this value in trace B. So how about port register? So let's take a look at the next example over here. So in this case, port B register is equals to 00001111. So this one means we write 0 volt or low signal, okay, to pin RB4, 4, 5, 6, 7. Okay, RB4, 5, 6, 7. So when you come across this notation, RB7, for example, RB7, so ada dua titik dia bertindih ni kan, RB4. So this one equals to RB7, RB6, RB5, and RB4. Okay, so ni maksudnya from RB4 to RB7. So if I say here we have RB0 to RB3, so this one comprises of 4 bits, that is RB0, RB1, RB2, and RB3. So this one we give value 1. In other words, we give a high signal to this pin. So high signal means the value of the pin is almost 5 volt. Okay, so this is more example about the trace and port registers. If we refer to the data sheet, okay, in PIC 16F FE4A data sheet, okay, so the registers associated with port A is port A registers and trace A registers. So here we have this address information as well, right? So what it meant here is that because microcontroller, okay, when we write the word port A in our program, so what microcontroller understands is that it needs to communicate with the location, okay, in address 05. Okay, so this is what the microcontroller understands if we write a port A in our programming. Okay, so 05 here is the location or the address of the register in the internal architecture of the microcontroller. So this H over here means that the address in its hexadecimal form. Okay, so in other words, if we convert this hexadecimal address into its binary form, then this is equals to the location 0000 0101. So this is in its binary. So let's take a look at the value on power on reset over here. So this is the default value upon start. Okay, so for port A, okay, for port A, the values are X, isn't it? It's equals to unknown. Okay, for trace A, the values are all equals to 1. In other words, upon power on reset, the values are all set as input for each of these bits. Okay, so this is the default value. And then if we look at the port B port, okay, so there are 4 registers associated to it. Port B, trace B, option write and incon. So port B and trace B we already see how does the values and how can we play around with the values. Okay, but for option write and incon, so basically this is associated with the properties, okay, of the port B, in which for RBPU over here, so this one stands for port B internal pull up registers, okay, because port B have a weak internal pull up registers connected to it internally. So if let's say we want to enable this, then we can enable the internal pull out through this BPU in option register. And the next one is incon register. So incon is actually interrupt configuration register. Okay, so as we had looked into before, there are several pins in port B that are associated with the interrupt, isn't it? For example, pin RB0 is coupled with external interrupt pin. So if let's say we want to enable the pin to become an external interrupt, so we have to set the respective value to bit INTE. Okay, so this one is a interrupt enable pin for external interrupt associated with RB0 pin. And then recall back, RB4 and RB7 also is one of the sources for external interrupt, isn't it? External interrupt or interrupt on change pin. So in order to set this pin to become an interrupt source, so what we need to do is we need to enable the interrupt through this RB IE pin. Okay, port B interrupt enable pin. So we have to give the appropriate value here to enable the pin. Okay, enable the pin. And then other than that is that, so let's say we already set that the RB4 to RB7 becomes an external interrupt pin. So how do we know there's an interrupt occur over here? How do we know? So this is where we can read through the state of the port B interrupt flag over here. So if that the RBIF equals to 1, meaning that there's an interrupt occur. Okay, there's an interrupt occur. So that's why this another two pins, another two registers over here is associated with a port B, because there are some connection in its bits over here with the port B pins. But anyway, by now, what you need to really understand is that the registers associated with port B, okay, is the port B registers and also trace B register. Okay, so trace B is to configure the input-output direction, while port B registers is to read or write to the port B pins. That's it. The rest we will look into from time to time. From time to time. So again, let's take a look at the internal architecture of the IC 16F84E microcontroller. Okay, so as we can see over here, there are many sections, isn't it? But actually, each of these sections has its own address. Okay, so maksudnya flash memory ada dia punya address dia, and then general purpose registers over here, RAM has its own address. Okay, and then EEPROM, okay, also has its own address. Okay, and timer 0 registers also has its own address. Okay, address, and then IO ports. Okay, the registers associated with it, which is port E, port B, and then trace A and trace B registers. So all of this has its own address. Okay, and status registers also has its own address. Okay, why is that? Because a microcontroller, okay, only knows the location, okay, or the address of each of this section when it wants to access the location. But us as designer, okay, or as a programmer, okay, so when we write our program, we write the program in terms of the name of the register, isn't it? For example, if let's say we want to access trace B, then we write trace B in our program. Okay, but then when this wording, okay, is being translated into the form that the microcontroller can understand, so the microcontroller will only understand that trace B is according to its address. Okay, so in this address link, we will look into the next video, okay, which is under the title Memory Organization. So this is just like a teaser to the content in memory organization for our next video. So in this video, we have looked into the input and output ports. So in which we know that in general each port has two registers associated with it. That is a trace register and also port register. So in the next video, we're going to look into memory organization and program counter and stack. Thank you.